There are various types of stepper motor. This type is a hybrid motor, which is the most commonly used. We see the motor consists of two end caps and the main body. The shaft sticks out from one end, and the electrical connections are usually found at the opposite end. Inside the motor, we see there are two bearings attached at either end of the shaft. These hold the shaft in place and ensure a smooth rotation. Attached to the shaft, we find the rotor. The rotor and shaft rotate together. The rotor is a permanent magnet, which has two halves known as cups. One cup is the north pole, and the other is the south pole. There are a number of teeth carved into the outer surface of each cup. The teeth of the two cups do not align. They are offset from each other so that the teeth of one cup aligns with the gaps of the other cup. Surrounding the rotor is the stator. The stator remains stationary and does not rotate. This consists of a number of coils of wire which surround the rotor. The coils are not all connected together. In this example, there are 8 coils, which are connected in 2 groups of 4. The driver will control when electrical current can flow through these coils. This creates an electromagnetic field which causes the rotation. There are teeth surrounding the inner perimeter of the stator also. These are used to enhance the precision of the motor and create magnetic alignment. The rotor has more teeth than the stator. For example, the stator might have 48 teeth, while the rotor has 50 teeth. This difference means not all the teeth will be able to align at the same time. When one set of coils is energized, the coils will form electromagnetic fields with north and south polarities. The rotor is a permanent magnet, and this will interact with the stator's electromagnetic field, causing the rotor to turn. The coils will turn on and off, and the polarity of a coil's electromagnetic field will reverse each time it turns on. This causes the rotor to rotate because the stator coils will attract and repel the rotor cup's magnetic field. There are 8 coils split into 2 groups of 4. The rotor has 50 teeth and the stator has 48 teeth. When the coils are energized, they create magnetic fields which interact with the rotor's permanent magnet. Looking closer, we can see that each time the coil polarity changes, it causes the rotor to turn one step, which in this case is 1.8 degrees. Notice that each time it turns, only the teeth nearest the north polarity stator coils align. All other rotor teeth do not. Remember, the rotor contains a permanent magnet, which is actually magnetized, meaning the poles are at opposite ends. So, while the rotor's south pole teeth align with the stator's north polarity coils, the rotor's north pole teeth align with the stator's south polarity coils. This design gives us very high precision and torque. Check out one of the videos on screen now to continue learning about electrical and electronics engineering, and I'll catch you there for the next lesson. Don't forget to follow us on Facebook, Twitter, Instagram, LinkedIn, and of course the engineeringmindset.com.